So let's look at number 18. This question also needs a lot of parts, so I might also make this question worth some extra points, but it doesn't have quite as many parts as the polynomial version of this. So I want you to graph f of x equals x minus 4 over x plus 2. Make sure you read the directions because I asked you to find a bunch of stuff, which means I actually want to see the work for all of that. So for the x-intercepts, we set y equal to 0. And for the y-intercept, we set x equal to 0. So we're going to set y equal to 0 here. But when you're trying to find a fraction equal to 0, remember you just really need to set the numerator to 0. Okay, 0 over anything is just 0. So if I set x minus 4 equal to 0, I get 4, okay, which is the point 4 comma 0. For the y-intercept, I'm going to find f of 0. So 0 minus 4 over 0 plus 2 gives me negative 2. Negative 4 over 2 is negative 2. So that is the point. It's y equal negative 2 or 0, negative 2. Okay, you're also supposed to find all the asymptotes. So for the vertical asymptote, notice we can't simplify this, right? So we just set the denominator to 0. So we get x plus 2 equals 0, or x equals negative 2. And then for the horizontal asymptote, remember this is the 3 cases thing. We just worked on that on number 16. So notice that the powers are the same. So we just pull the leading coefficient of the top over the bottom. Notice that understood number on both is 1, so it's just going to be y equals 1. Okay, so now the point is to put all of that together and kind of see what the graph looks like. So once you've found all of those pieces, we're going to graph them. So I'm just going to go out maybe 5. So let's graph what we know, right? We know the x-intercept is at 4. The y-intercept is at negative 2. We know that there's a vertical asymptote at negative 2 and a horizontal asymptote at 1. So remember, we do asymptotes with dashed lines because they're not actually part of the graph. They just represent a boundary line for the graph. So I think this piece, if you remember what these look like, is kind of already set in stone, right? It's got to scoot close to those intercepts without actually crossing them. The big thing I don't really know about is over here. Okay, like I know what this piece looks like, but I have no information on the left-hand side. So when you go to pick the additional points, and just like before, you won't know what those are until you graph what you already have. But I'm going to not pick negative 2, right? I can't. That's where the asymptote is. But I'm going to do negative 3 and negative 4, since those are literally the 2 values to the left of the vertical asymptote. And don't forget what you do with these, right? We plug these in. So use your calculator if you must, okay? But I'm going to slide this down a little bit. We're just plugging them in here, right? So negative 3 plugged in would give us a negative 7 over a negative 1, which is 7. And plugging in a negative 4 would give us a negative 8 over a negative 2, which is 4. So I think we can graph that. Okay, I just need to go up to 7, and it looks like I only went up to 5, so I'll just go up just a little bit more. So I've got a point at negative 3, 7 here. Let's get rid of my question mark since it's in my way. And then negative 4, 4, so about here-ish. And so we just need to kind of curve it up and kind of around here. Okay, so I kind of ran out of room there because of the top of my paper, but you get the idea. Okay, so the asymptotes should have the graph scoot as close to it as possible without actually touching or crossing it. All right, so last one about the rational graphs. Describe the changes in the graph from 1 over x. Okay, so the first one, notice it looks like 1 over x, except I added, or subtracted rather, a 2 inside the function. And so this is inside, so this is going to be a shift right 2 change. Remember, horizontal changes work opposite of the way you might have expected. For b, we've got 1 over x plus 4. So notice this time the plus 4 is at the end. So this plus 4 is going to shift it up 4. And then last but not least, we've got 1 over x plus 1 minus 6. So we've got 2 changes, right? Right here and also right here, right? So this is going to be a left 1, and this is going to be a down 6. Okay. Just to remember that there are 6 total transformations, and so you might need to go back and look at some of those other ones. Remember, if we do a negative sign, it's a reflection, right? A negative sign to the front of the function is a x-axis reflection. A negative sign inside the function would be a y-axis reflection. And then we can also have the vertical and horizontal stretches and shrinks. All right, so last but not least, solve the linear inequality. Okay, so the first thing that you do is you figure out what it would have been if it were an equals problem. So you kind of just set this equal to 0, and if it's not already equal to 0, you move terms around. So notice these have an x in common. So I get 0 and I get 4. So those aren't my answers, those are just going to be my boundary points. So I'm going to mark 0 and 4. And then I'm going to choose some test points in every section to see if it works. Okay. In other words, I'm going to pick some test points and I'm going to plug them in. So plug them into the original function. So you can go back to the most recent notes if you need to for this, but I'm going to pick -1. I'm going to pick 1 in between 0 and 4, and then I'm going to pick 5. Okay, so the question you're asking yourself is, do you get a true statement or not? Okay, so I go back to the original a lot of times, but if you plug in -1, you're going to get 1 plus 4 is greater than 0, which is true, right? So I'm going to say true when plugged in. So this is a yes. But when you plug in 1, you get 1 take away 4, which is -3. That is not greater than 0, so that's a no. So I'm not showing quite all the work that I did in class. You'll need to look back at your notes for that. And then lastly, if you plug in 5, you're going to get 25 minus 20, which is 5, and that is bigger than 0, so we're good there. So then the solution, as I'll want to see it on the test, is read the number line, what you have. So it's -infinity to 0. And then you go back up here and see if you have greater than or equal to or plain old greater than. I have greater than or equal to, so it's a bracket. And then 4 to infinity. And then last but not least, I've got this one. Okay. Remember that we want to make sure that the denominator isn't 0 in this case. We didn't have that problem in number 20 because we didn't have a fraction. So if the denominator can't be 0, then x can't be -3. Okay, so I'm going to need to make sure and remember that. Okay, but then you just set the top equal to 0 and the bottom equal to 0. So here you get x equals 4, and here you get x equals -3. Okay, these show up on your number line. These are what we call boundary points. So let's draw our number line and then we'll do our test point thing. So here's -3 and here's 4. Okay, I do need to go ahead and kick out -3 though, so I'll go ahead and put an X mark above there. So again, you're going to pick test points. Okay, and you're going to plug them in. So I'm going to pick something to the left, which would maybe be -4. Something in between the two could be 0. Something to the right could be 5. And then you're just going to ask yourself if it works when you plug it in. So you might need a calculator if you don't want to do things in your head. So if you plug in -4, you're going to get -8 over -1, which is 8. So is 8 less than or equal to 0? It is not, right? So this is no. This is a false. So this section is a no-go. If you plug in 0, you get -4/3, right? Is -4/3 less than 0? It is. And then lastly, plug in 5 and you get 1/8. And 1/8 is not less than or equal to 0, right? It's not negative, basically. So that's a no. Okay, so then the solution for this one, just be really cautious. I'm going to squeeze it in here. The solution is generally going to be a bracket type situation, but because we want to get rid of the 3, or the -3, we're going to say parentheses for -3, but then 4 with a bracket. Okay, so it had a bracket here because it was less than or equal to instead of plain old less than, but then we had to kick out -3. Okay, so that is basically any and all questions that you could expect to see on test 2. Make sure that you go back and look at your notes and go back to My Math Lab. You can go in through the grade book at any time and see your old assignments and get it to give you some more questions if you'd like. Okay, so just make sure you're doing all that you can. You practice or study for a math test by practicing problems, so make sure that you're practicing as many as you possibly can. Okay, the review may not have as many practice problems as you need, so you may have to seek out some of those on your own.